who is Wang, and he is a professor and a co-founder and president at AM Batteries, and it's once again in the domain of electrodes because AM Batteries is a company specializing in dry electrode manufacturing, and that's also the topic of the talk today. It's dry electrode manufacturing technology, an enabler for low-cost batteries. So please take it away from here.
Oh, thank you. Thank you very much. Hello, everyone. My name is Wang. Today, I'm going to talk dry electrode manufacturing technology, an enabler for low-cost batteries. So here's some takeaway. Here's some like a AMB overview. So AM batteries, we offer the turnkey dry electrode manufacturing solution to the battery manufacturers. So why the AMB technology is so important? So we can enable 60% lower OPEX, 30% less CAPEX, and also 5 times smaller footprint compared to conventional slurry coating method or slurry coating equipment. So but as most of you guys know, the battery market is the margin is low. So whatever the technologies can help lower the cost and while keep the same performance. So eventually battery companies they have to adopt it. So otherwise probably they cannot be cost competitive. So far AM batteries we have 47 full-time employees with a dozen of contractors. Most of us are engineers. So in the last 3 years we raised $74 million. So the funding is mainly used to build a facility and also try to do some demonstration for a bigger scale equipment. So right now, our major job is we are developing our almost half gigawatt hour capacity engineer pilot line. So so we are getting there. So again, this is a conventional electrode manufacturer process, and I don't know. You can see my mouse here. So again, all the process start from you have to mix the cathode powder or anode powder with some solvents. So cathode side is NP, water anode side people can use water. Then you add some conductive carbon or conductive carbon powder or carbon nanotube to make the slurry. So after you spend a few hours to make the slurry, you do the slurry coating, cast onto the current collector. So current collector is a cathode side is aluminum foil, anode side is copper foil, because you have a solvent now, so you have to dry it. And also for the cathode side, and you cannot emit the NP solvent to the air. You have to recover it. So because today is electrode manufacturer is pretty advanced, and people are targeted at minimum is 50 meter per minute to 100 meter per minute. So that means the drying oven can be very long. So because you need to allow enough time to dry the electrode. So a few years ago, we did some analysis. We want to find in the battery manufacturer. So what step is the limiting step in terms of cost, energy, footprint, and also the throughput. So so all the directions are pointing to the slurry coating electrode. So so here on the right hand side of the slides, I show some numbers. So for example, drying and solvent recovery, they account for 47% of energy consumption. That means when people make the batteries, almost 50% of energy they are used for drying the solvents and also recover the solvents. And also the slurry, the mixing, coating, drying, and the solvent recovery, they also account roughly 30% of manufacture cost. So right now, the market, the capital equipment for those steps is roughly $66 million for 5 gigawatt hour plant. That means per gigawatt hour, a plant, you need roughly $30 million. But of course, this number can be changed. Depends on where you source the equipment, and what's the exact requirements. And also the electrode slurry coating and drying equipment, they can account for